This is remembrance-kjv.com, video number 11. You are welcome. In this video, we take a look at additive notation as a key notation for the doubling trig. When teaching number times for the first time, a child is first taught to chant number times for 2. The child goes on like this: 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. When a child is then required to find the value of 8 times 2, the child first counts 8 counters, then starts chanting from the first chant to the 8th chant like this: 2, 4, 6, 8, 10, 12, 14, 16. 16 coincides with the 8th count. Therefore, the solution for 8 times 2 is 16. The chanting of these doubling times is easy from 2 to 10. But beyond 10, it takes time for a child to manage the times. Let us add some understanding to how these doubling values can be studied. In Roman numerals, 6 is VI, which is interpreted as 5 and 1. 7 is VII, which is 5 and 2. And 8 is VIII, which likewise is 5 and 3. This way of representing numbers is known as additive notation, where a number is understood as a sum of other numbers. The double of 6 is understood as the double of 5 and the double of 1. The double of 5 is 10 and the double of 1 is 2. The double of 6 is therefore 10 and 2, which is 12. The double of 7 is understood as the double of 5 and the double of 2. The double of 5 is 10 and the double of 2 is 4. The double of 7 is therefore 10 and 4, which is 14. The double of 8 is understood as the double of 5 and the double of 3. The double of 5 is 10 and the double of 3 is 6. The double of 8 is therefore 10 and 6, which is 16. Let us invent a notation that, unlike Roman numerals, does respect positional values and express all numbers above 5 like this. 6 is 1 with a dot above. This is understood as a number that is 1 more than half the base. 7 is 2 with a dot above. This is also interpreted as a number that is 2 more than half of the base. This goes on until we get to 9, which is represented as 4 with a dot above. Let us also remove Roman numerals, that we may get a clearer view of the notation and its doubling trend. It can be observed that the unit values of the doubles of the numbers 6 to 9 are respectively similar to those of the numbers 1 to 4. So, when doubling, say 8, it should be understood mentally that 8 is the sum of 5 and 3. Double 5 is 10 and double 3 is 6. The result is therefore 10 and 6, which is 16. 9 is dot 4. Double 4 is 8. The double of dot 4 is therefore 18. For numbers above 5, their doubles are prefixed with 1, and their unit values are equal to the double of the number below the dot. When doubling digits, the highest carry digit is 1, and it exists for the doubles of digits 5 and above. With this in mind, let us try and double the number 7465 83 912. 7 is .2. Double 7 is 14. But before we write 14, we check for a carry digit from the succeeding computation of the doubling of 4. 4 is less than half the base. Therefore, there is no carry digit and we write down 14. Double 4, 8. Check above 5, so we write down 9. 6 is .1. Double .1, 12. Check 5, so we write down 3. Double 5, 10. Check above 5, so we write down 1. 8 is .3. Double .3, 16. Check below 5, so we write down 6. Double 3, 6. Check above half, so we write down 7. 9 is .4. Double .4, 18. Check below 5, so we write down 8. Double 1, 2. Check below 5, so we write down 2. And lastly, double 2 is 4. Therefore, the double of 74, 65, 83, 912 gives 14, 93, 16, 78, 24. With this talent in our mind, let us repeat the doubling of this number. 8472, 659. Let us do it faster. 16, 9, 4, 5, 3, 1, 8. The result of the doubling of 8472, 659 is therefore 1694, 53, 18. Let us again double 1694, 53, 18. It's 3, 3, 8, 9, 0, 6, 3, 6. The doubling of 1694, 53, 18 is 33, 89, 06, 36. I think many will realize that a person trained in mental arithmetic doubling can arrive at the product of 8472, 659 by 4 faster by repeated doubling than by use of the Greco-Babylonian approach. This lightning fast doubling also makes us desire to reconsider multiplication by way of Egyptian doubling, computations that we shall consider in video number 13. Let us consider how additive notation can also be used to manage other multiplications apart from doubling. Let us take for an example the multiplication of 8 by 6. It is easy to multiply a number by half of the base. One has to first multiply by the base, the result of which is merely to suffix a 0 to the multiplicand. Then the result is halved. For an example, 8 multiplied by 5. The result is got this way. It is 8 multiplied by 10, which is 80. Half of 80, that's 40. So the multiplication of 8 by 5 is 40. 8 multiplied by 6 is the same as saying 8 multiplied by dot 1. Dot 1 is 5 plus 1. This multiplication is interpreted as the multiplication between 8 and the bracket of 5 plus 1. 8 by 5 is 40, and 8 by 1 is 8. The solution is therefore 40 plus 8, which is 48. 8 multiplied by 7 is the same as 8 multiplied by dot 2. This is computed as 40 plus 2 multiplied by 8. 2 multiplied by 8 is 16. 40 plus 16, that's 56. So 8 by 7 is 56. To find the solution of the multiplication between one digit and a high complex number, a child arrives at the solution by first splitting the high complex number into its additive equivalent. By so doing, the child applies reasoning and avoids the use of rote chanting and sluggish approach of finger counting. Let us take a look at how algebra can be compounded with additive notation to manage multiplication. 6 times 7 is dot 1 multiplied by dot 2. This is analogous to the bracket of x plus 1 multiplied by the bracket of x plus 2, in which x is 5. The algorithm gives the base value, which is equivalent to x plus 1 plus 2, and a unit value of 1 times 2. X is 5, and x plus 1 plus 2 is 5 plus 1 plus 2, which is 8. The calculation gives 8 fives and 2 units, which is 42. 7 times 8 is dot 2 times dot 3. Using the same algorithm, the calculation gives the number of fives that are equal to 5 plus 2 plus 3 and a unit value of 2 times 3. 5 plus 2 plus 3 is 10, and 2 times 3 is 6. The solution is 10 fives and 6 units, which is 56. As has been noted, there is not a single method of managing number times. There are a variety of them. This is aided by the ability to express digits as either sums or differences of other numbers in a combination in which one of the numbers is either a factor or a multiple of the base. Choose your own numbers and practice doubling and multiplication using additive notation. Thank you. Do not forget to subscribe to this channel. Meet you in video number 12, where we will take a look at Yoruba number system.